Okay, so any objects that are moving have kinetic energy. And we can represent energy in this case as capital E with a subscript K, or kinetic energy. And the amount of kinetic energy that an object has is dependent on its mass and velocity. So we know it's already moving because it's got kinetic energy. We have this relationship here where it's a half mv squared. So we're still talking about measuring the mass of our object. Our mass is in kilograms and our velocity is in meters per second. This is a vector quantity, the velocity, but we know the energy is a scalar quantity, as is mass. So if we look at the worked example, we have the kinetic energy of a baseball, and the ball has a mass of 120 grams. So we're going to need to convert that to kilograms. So we're going to divide by 1,000. So we determine its mass in kilograms, and it is travelling with a velocity of 35 meters per second. It hasn't told us the direction, but it doesn't matter because we know we're calculating energy and we don't need the direction. And we want to work out the energy. Bk will equal a half times 0.120 times 35.0 squared, then, which gives us 73.5 joules. The second example, the kinetic energy of moving cars is of interest to people investigating road accidents. For example, the kinetic energy of an average small car with a mass of 1.4 tonnes when travelling at 60 kilometres an hour can be calculated. So we want to find trying to find kinetic energy. Our mass is 1.40 tonnes. So we have to multiply this by 1,000 to convert that into kilograms. And our speed was 60 kilometres an hour. What do we do if we want to convert that to meters per second? Do we multiply or divide by 3.6? Divide? Multiply. If we multiply that by 3.6, we're going to end up with a very large number. So we're going to divide it by 3.6.
That's what I was meant to say. I was using pronunciation now. I said it wrong.
And we have then our velocity of 16, well, it's 0.6 repeater meters per second. So we now have our variables in our SI units, and we can substitute into the formula. Which then gives us 195,000 joules, or 195 kilojoules. So that's a lot of energy, isn't it? Which is why car crashes can cause a lot of damage to the cars and the occupants. Now, worked example 3 is on page 20. Now we have the velocity of a shot put. It has a mass of 5 kilos. And it has a kinetic energy of 160 joules. And we want to find the velocity. So if I rearrange this, I would multiply both sides by 2. And then divide both sides by m. And so then the velocity will equal the square root 3k on m. And that's not how they've done some calculations without having rearranged it all for that. So it doesn't really matter. Square root of 2 times 160 divided by 5. Assume the answer is correct in the book. 8.00 meters a second. Okay, so at the moment we're looking at these two formulae separately. And, we're only concerned with one kind of mechanical energy. You can go on then and work on questions in set 6 if you're up to that, or you can continue on with the questions